Okay, today we're going to be going over some questions from the textbook to find the tangent and normal vectors along with curvature. So first we have question 19, part A, which is finding the tangent and normal vectors of our position vector, which is t squared sine t minus t cos t and cos t plus t sine t. So our first step is finding our velocity vector, which is just the derivative of our position vector, which will be 2t cosine of t minus, in brackets for our second part, which will be cosine of t minus t sine of t. And this will be negative sine of t plus sine of t plus t cosine of t, which will give us 2t cosine t minus cosine of t plus t sine of t, and this will give us negative sine of t plus sine of t plus t cosine of t. And if you notice, our cosine and negative cosine cancel, and same with our sine, which just gives us 2t t sine of t and t cosine of t. And now to find our tangent, we not only need our velocity, but we need to find the magnitude. So this will give us the square root of 4t squared, because we just have to square root all of the terms. So this will be plus t squared sine t squared t plus t squared cosine squared of t. And then we could make this the square root of 4t squared plus, and then factor out a 2t here, or a t squared here, which will give us sine of t plus cosine squared of t, which this will just become 1. So now we get the square root of 4t squared plus t squared, which gives us t root 5. So now finding our tangent vector, our t of t, will be equal to our velocity, which is 2t t sine of t and then t cosine of t divided by the magnitude, which is t root 5. And then if we divide all of them by a t, this gives us our tangent equal to 2 divided by root 5 sine of t divided by root 5 and cosine of t divided by root 5. And now we have to find our normal vector. But if you remember, our normal vector, or n of t, is equal to the derivative of our tangent vector divided by the magnitude of the derivative of our tangent vector. So our first step is going to be finding the derivative, which is going to be equal to, since 2 over root 5 is just a constant, this becomes 0. And since root 5 is a constant, we can just deal with that. We can just take it out of the differentiation and add it after. So this will make it cosine of t divided by root 5. And this will become negative sine of t divided by root 5. And then to find the magnitude of t prime of t, it's the square root of cosine of t divided by root 5 all squared plus negative sine of t divided by root 5 all squared, which gives us the square root of cosine squared of t divided by 5 plus sine squared of t divided by 5. Now if we factor out the 1/5, this will just become 1/5 cosine squared of t plus sine squared of t, which just equals to 1. So this gives us our magnitude is equal to the square root of 1/5. So now since we have both parts, we can put it into our formula to find the normal vector, which is going to be 0 divided by 1/5 cosine t divided by root 5 divided by root 1/5, and then negative sine of t divided by root 5 divided by root 1/5, which will just simplify to 0 cosine of t and negative sine of t. Which gives us our final answer for part A. So now for question 19, we have part B, which is asking to find the curvature. And the curvature is equal to the magnitude of t, the derivative of the tangent vector divided by the magnitude of the velocity vector, which is going to be equal to the square root of 1/5 divided by t root 5, which is going to be equal to 1 divided by root 5 multiplied by t multiplied by root 5, which will give you 1/5t as our curvature. So now we have question 20, which gives us our r of t is equal to 5 sine of t, t, and 5 cos of t. So again, our first step is always going to be finding the velocity and the magnitude of the velocity. So our velocity here is going to be equal to 5 cosine of t, 1, and negative 5 sine of t. And to find the magnitude of this, we square root it and square all our inside terms, which will be 25 cosine squared of t plus 1 plus 25 sine squared of t, which again, if we make this equal to 1 plus 25 cosine squared of t plus sine squared of t, this just becomes 1, and it'll be 1 plus 25, which will be the square root of 26. Which gives us all the information we need to find the tangent vector, which is going to be equal to 5 cosine of t, 1, and negative 5 sine of t, all divided by the square root of 26. Then we need to find the derivative of t, of our tangent vector, in order to get our normal vector. So t prime of t is going to be equal to negative 5 sine of t, 0, and negative 5 cosine of t, all divided by the square root of 26. Then to find the magnitude of our tangent, we square root it all, which will give us negative 5 sine of t divided by square root of 26 all squared, plus negative 5 cosine of t divided by root 26 all squared, which will give us the square root of 25 sine squared of t divided by 26 plus 25 cosine squared of t divided by 26, which if you factor out the 25 over 26, this will get you 25 over 26, and then sine squared of t plus cosine squared of t, which is 1. So this will give us our final answer of the square root of 25 over 26, which is the same as 5 over the square root of 26, which now gives us all the information we need to find our normal vector, which will be equal to -5 sine of t divided by square root of 26, 0, and -5 cosine of t divided by the square root of 26, all divided by 5 over the square root of 26, which will cause these to cancel, giving us our normal vector is equal to just the negative sine of t, 0, and negative cosine of t. And now finally we need to find our curvature, which is going to be equal to the magnitude of our tangent prime of t divided by the magnitude of our velocity, which is going to be equal to 5 over root 26 divided by root 26, which gives us our final answer of 5 divided by 26 as our curvature.